Hey guys, it's Mr. McHugh, and I'm going to walk us through two examples of calculating all six trig functions for angles in two different right triangle situations. So the first one here is we're going to find all six trig functions of either acute angle set in the context of a right triangle with a leg of 4 and a leg of length 6. So let's start by drawing ourselves a right triangle. And because this side here is the shorter, this leg is the shorter leg, I'll label that one to have a length of 4. This one then has the length of 6. That's our leg A and our leg B. Typically we say that the side C is the hypotenuse, so that's how I knew that the problem, having labeled our sides A and B, were the two legs, and then our hypotenuse is still the one that we don't know. So how do we find the length of the hypotenuse? We use the Pythagorean theorem, which states that if we square the legs and add them together, we'll arrive at the square of the hypotenuse. So 16 plus 36 will be our hypotenuse squared. Oops. 52 is c squared. We're going to solve for c by square rooting. And because we're dealing with sides of a triangle, we don't have to worry about the negative root. This is going to be 2 root 13. So we can finish labeling our triangle with a hypotenuse of 2 root 13. That's our hypotenuse. Now the problem here says either acute angle, so we can choose either this acute angle or this acute angle. Let's pick this one, and by choosing that, then that makes the 4 our opposite side, and it makes the 6 our adjacent side. And of course the 2 root 13 is our hypotenuse, no matter which angle we pick. Now the opposite and adjacent would be flipped if we had picked the other angle. So knowing opposite, adjacent, and hypotenuse, we're now ready for our 6 trig functions. Let's start with the sine of theta. The sine is the opposite 4 over the hypotenuse 2 root 13. We don't want a square root in the denominator, so we are going to rationalize that denominator, and we're going to end up with 2 root 13 over 13. Cosine theta, if we think SOHCAHTOA is the adjacent 6 over the hypotenuse 2 root 13, again we're going to rationalize and come up with a final simplified answer of 3 root 13 over 13. And then tangent of theta is opposite over adjacent, so that's 4 over 6, reduces to 2/3. So those are our first three basic. The other 3, the reciprocal trig functions. The cosecant of theta is the reciprocal of the sine. Now if I take the reciprocal of the final answer, if I take the reciprocal of this, I'm going to put the square root right back into the denominator, which I don't want to do because we did all the work to get it out of the denominator. So I'm going to take the reciprocal of this, and which is essentially the hypotenuse over the opposite, and by doing that we will not have to rationalize. So 2 root 13 over 4 reduces to root 13 over 2. Same thing for the secant. No sense in taking the reciprocal. We can just do the hypotenuse 2 root 13 over the adjacent 6 and reduce that to root 13 over 3. And then finally the cotangent. We can do the reciprocal of the tangent's final answer here, this 2/3, and the reciprocal, of course, is 3/2. And that's how we find 6 trig function values for an angle set in a right triangle where we know 2 of the side lengths. And on the second example, to try to find the 6 trig function values of an angle set in a right triangle is when we're given one of the trig function values to begin with. That tangent of theta equaling 1/3 unlocks the key to the side lengths of this right triangle that we can set theta in, because we know that the tangent is the opposite over adjacent. Then we can create ourselves a right triangle where if we put in an angle theta, let's put it here, call this angle theta, then the opposite side has a length of 1 and the adjacent side has a length of 3 because of the ratio given to us as the tangent. So now we've got, again, 2 of the sides lengths 1 and 3. We've got to do the Pythagorean theorem again on these side lengths to calculate the hypotenuse, C, and we'll find that the square of C is 10. If we solve again using the square root and ignoring the negative root because of the side length of a triangle can't be negative, we'll get that C, the hypotenuse, is the square root of 10. And so that's a way to get to the same place we were at previously, where we knew the length of the adjacent, not the adjacent, we knew the length of the opposite, the length of the adjacent, and we had to calculate the length of the hypotenuse. Knowing those 3 side lengths now, the calculation of the 6 trig functions, actually we already know the tangent, so it's really just 5 trig functions left, is the same process where the sine of theta is opposite over hypotenuse, 1 over root 10, which again, if we rationalize, we get an answer of root 10 over 10. The cosine of theta adjacent over hypotenuse, rationalize, and we get 3 root 10 over 10. Tangent we were given, so we don't need to calculate that. That was 1/3. And we'll take the reciprocal definitions of cosecant, secant, and cotangent to calculate these trig function values. So hypotenuse over opposite for cosecant is just root 10. Hypotenuse over adjacent is root 10 over 3 for cosecant, and then cotangent adjacent over hypotenuse is 3. So a little bit different on the second example to get started, and then we finish the same way once we know all 3 side lengths.